This is MATHguide.com, and my name is Mark Karadimos. In this video, we're going to talk about how to calculate the value of items over time. And this requires the use of a formula, and it's based off of exponential growth or decay. So the sections in this video are, well, the first section we're going to talk about what the formula is and what the variables stand for. In our second section, we're going to go over an example. The example will cover a car, and the car will depreciate over time. And then in our last section, we're going to go over an example dealing with a diamond, and the diamond will appreciate over time. Okay, so those are the sections of the video. Now, before we get to those sections, I'd like to inform you that MATHguide.com offers a variety of educational materials besides just these instructional videos. We also offer text-based lessons and interactive quizzes. Okay, and it forms a comprehensive package with these videos, because after you watch the video, you can check out little details maybe that you thought you knew, you're not sure if you didn't know, but you can check out the lesson, look up all the details if you like. Sometimes the videos, most of the times the videos do the trick, but you always also have that there. And also we have the interactive quizzes, and the interactive quizzes will throw you a random problem, and it'll check several steps along the way and tell you if you're doing these problems correctly or not. So I strongly advise you to check out, for instance, that interactive quiz after this video to see if you really have mastered it. Okay, all right, so let's get started. So here's the formula that we're going to use when it comes to dealing with exponential growth or decay with values that change over time. And let's describe the variables for this problem, which means the letters, right, when we refer to algebra. So let's talk about that small case a. The small case a stands for the initial or starting value of whatever item we're talking about. The R stands for rate. So what is the rate? And usually it's referred to in a problem as a percent. T is, of course, our time. And the big A, or the capital A, stands for the final amount. The final amount of whatever this item we're talking about. Okay, so a couple words of caution that when you're using this formula, notice there's a plus or minus sign. The plus stands for things that appreciate over time, and of course the minus stands for things that depreciate over time. All right, so you have to be aware of that when you use the formula. Your rate and your time have to be in the same units. So usually rate is in an annual yearly amount. It doesn't have to be. And then if that's the case, then time also is in years. So if you have a 4% growth rate per year, then time is obviously going to be in years also. So R and T have to match as far as the length of time, those units. Also, if you're given, let's say, a rate of 3.7%, remember, percent means out of 100, so that would be 3.7 divided by 100, so that would be 0.037. And you would use that decimal value when you plug it inside the formula for R. Okay? All right, it's a lot of talk. Let me show you how this formula is used by looking at a couple specific examples. All right, so here's our first example. We're dealing with a car that is presently worth $16,000. If it depreciates at a 3.2% annual rate, what is its value in 5 years? Okay, so what you're going to do is, of course, toss this into a formula. If I have this formula, I'm going to plug in some numbers in there and see what happens. So I want to figure out what is the final amount, what's the final value of this car. That's big A. Our little a is 16,000. I don't put commas in when I do math. Too confusing. And of course, I'm talking about depreciate. That means we're subtracting value over time. All right, so our rate is 3.2%. Remember, 3.2% means 3.2 divided by 100, so there's a 0.032. Okay, and of course I want to figure out what will be this value in 5 years, and that's our time. Notice the rate is annual, time, annual, yearly. Okay, so it's all matching. Our units match. So first thing I like to do, I could plug this into a calculator right now if I wanted to, but I'm going to subtract. Okay, when I subtract these, I'm going to get 968, right? Yep, I check, make sure my math is accurate. I always like to see this because it's kind of important that if you're subtracting 3.2% per year, that means you're retaining 96.8% per year. It's kind of two sides of the same coin, right? You're losing 3.2 or you're retaining 96.8. So the formula wants to know what is it retaining per year. Anyhow, you feed the formula. Now you just plug this into a calculator and you're going to get, obviously I've done this earlier, it's 13,598 and 68 cents. And of course you're going to round this always to the nearest penny, because we're talking about money. So there you go. There's your amount. It's just that easy. All right, let's go on to the next problem. All right, here's our second problem. We're going to use a example here with a diamond. And usually precious metals and precious stones go up in value over time. So, and this is one of those situations. So let's say we've got a diamond that's appraised at $5,000. That just means that's its current value. If it appreciates or goes up at a 2.5% annual rate, what will be its value in 15 years? So again, I've got my formula. So I'm going to throw into the formula what I know. So A, or big A, is the final amount. That's what I'm interested in. So I'm going to plop in $5,000 for its current value. It's appreciating, so I'm going to put a plus. I'm going to put in the rate, so 2.5% means 2.5 divided by 100, or 0.025. Okay, and of course time is 15, and our units match. This is an annual rate, and of course time is in years, so our rate and time are synced up. Okay, so let's plug this in. Well, not yet. I'm not going to plug it into a calculator yet. First thing I'm going to do is add these two, and this is going to be a 1.025. So that means the 1 stands for you keep the original amount, but now you're gaining 2.5%. So since our value, or our base of our exponential growth model, since that value is greater than 1, this base is greater than 1, that's why it does represent a growth model. If this base is less than 1, it indicates a decay model, which was our last problem with the car. Okay, anyhow, let's plug this into a calculator, which I did earlier, and I'm getting 7,241.49. Again, I rounded it to the nearest penny. And that's it. So it looks like this thing gained over $2,200 in 15 years. Very nice. Okay, so again, make sure you go back to MATHguide.com, check out our text-based lessons, and really you're going to benefit by our interactive quizzes. And we do have one on this. Check out our description. I got links there for you. Okay, take care.